Okay, for cell 2C, we're going to talk about outside angles. So it's the fourth one in our group. You can see over here I've listed the three that we've already done: central angles, inscribed angles, and then the last lesson was just on inside angles. So guess where the vertex is on the outside angles? Yep, it's outside the circle somewhere. The measurement of an outside angle is equal to 1/2 the difference of its intercepted arcs. Okay, and there's kind of three different scenarios here that I've got listed here. It does help if you have two different colors of pen or crayon or markers or highlighters, whatever, so that you can easily see the arcs that are needed. So for example, angle 1, here's the vertex, so it's an outside. This one hits the circle here and here. Okay, so there's one of its arcs. The other arc is going to continue out here, but then it's going to come back here. Since this is a tangent, it only hits the circle once right here. So the measure of this angle is equal to this arc minus this one divided by 2. Okay, so this one is finding the difference, which is a subtraction. If I take half of something and if I divide by 2, it is the same thing. Angle 2 is an outside angle. It is formed by these two tangents, and the two tangents are going to be from P over here to R and from PQR. Okay, now if you look at that, the whole circle has been highlighted. So 360 degrees would be a good one to remember for this problem. And a little bit later, I'll tell you a little shortcut on that one. Angle 3 out here, outside angle, formed by two secants. It hits the circle. This arc here would be one of its inscribed circle, or intercepted arcs. And then XY out here would be its other intercepted arc. So the measure of this angle equals this arc minus this arc divided by 2. All right, so let's take a look at some examples. So the first one here, we want to find the measure of angle DBR. DBR. So we want to find this outside angle here. If I follow the sides of that angle, it hits the circle here at AR, which is 60. And then it's going to hit the other side here from D all the way back to R. Okay, so it's very similar to this one right above it that we looked at. So the measurement of this angle is equal to the difference of those two arcs divided by 2. So the difference is going to be 130 divided by 2. That angle outside here is 65 degrees. Next one, if I want to find angle RQU, so that's this angle right here. It's an outside angle. If I follow the sides out, these are both tangents, so from U to R is one of my arcs. And the major arc going on the other way is also the intercepted arc. So this angle outside here is going to be the difference divided by 2 of those two arcs. So 270 minus 90 is 180. Divided by 2 gives me 90 degrees. This angle right here is 90 degrees. Even kind of looks like it. Number 6. This angle N that we're trying to find is an outside angle. Okay, if I follow the sides out of these two secants, you can see here I've got two arcs. This is probably the easier ones because the two arcs now are there. I'm going to subtract them and divide by 2, and that will give me this angle out here. So 80 minus 35 is 45. Divided by 2 gives me 22.5 or 22.5 degrees. Okay? Now, these last two go along with these two here in the center. Okay? And if they give you the arcs like this, then it's just as easy, just go ahead and subtract them and divide by 2. However, if they give you something like this first one here, it can get kind of, I don't know, call it fancy, but it is possible because I know this angle is an outside angle. That angle equals from V to T, that arc, and the other one, which is all the way around here. This orange arc and the green arc need to total up to 360. Okay, so if I make this one let's just call it x. And that would mean, how am I going to find this outside arc? Well, all the way around is 360, so this would have to be 360 minus x. So what's our rule say for this angle outside? I'm going to take the two arcs, find their difference, and divide by 2. So that would look like this. The angle equals the arcs, there's the orange one, minus the other one, divided by 2. This is not the shortcut, by the way. I'm just showing you the full way here. Okay, so we've got this little equation we got to solve. So 36 equals this. So we can multiply by 2 to get rid of the fraction piece. Okay, I'm going to do it right up here. 72 equals 360 minus 2x. I'm going to combine those like terms. I'm going to subtract 360. So when I do that, that gives me negative 288 equals negative 2x. Divide both sides. So x equals positive 144. If you remember, x was this arc here, that's 144. We could also find this one outside here if we needed to, just by taking 360 minus the 144, and that would tell me this orange one. Okay? Now I want you to look at, there's a relationship here, and this is only true for an outside angle formed by two tangents. Okay? That is the relationship between this angle and its first arc. Look at the relationship, 36 and 144. Look at this one, 90 and 90. Well, 36 and 144 also add up to be 180. So the outside angle and this one inside here will always add up to be 180. If you don't like that little shortcut, you can do all of this. Up to you. Okay? But it's just, again, it's something else to remember. But if you can remember, as in the case of all these other ones, if I subtract, find the difference, and then divide by 2, that will give me my angle. So using that little shortcut, let's do that real quick here. It's getting a little long. So the outside angle formed by two tangents, this first arc is given to us. We know that's 110. These two, angle Q plus arc RP, has to total 180. So if angle Q is what we're trying to find, plus 110, angle Q will equal 70. And if you went this way, it would be the same thing. So if you have any questions, if that confused you, please let me know and I'll come around and help you.